I like to start with this chart up here. This is actually something that the DOE put together because it kind of gives this sense of hydrogen is being thought of in all these different ways of making it, all of these different potential markets. Lynn talked about some of the potential decarbonization options. Hydrogen's being thought of in a lot of different ways. And so one of the big things I want you to take away from thinking about hydrogen is that at least right now, it's an energy carrier, kind of like electricity, right? It is not a resource. It is an option for carrying the energy that we need for different things. And so there are decarbonization applications, but it is not one of our energy resources, and we're going to talk about that. But there's a lot of ideas, a lot of potential. Since we were just talking about criticisms and the oil industry's interest in carbon capture, the oil industry has a lot of experience in hydrogen as well. So hydrogen has faced some of the same criticisms. Is it really this clean energy solution, or is it just something that the oil industry supports because it's something that they have a lot of experience? They can make money in the hydrogen space. So just something to keep in mind as we're talking about this. Okay, we had some reading in the videos. Our hydrogen's cross-cutting. Let's talk about kind of a summary of what we're going to talk about with hydrogen and then get into some of the details. So mentioned it's an energy currency, not a resource, at least not yet. And we'll talk about what that means. It's a very simple molecule. One proton, one hydrogen electron is our hydrogen molecule. Hydrogen H2 is the form that we use. Burns or reacts really easily. So we'll talk about how that's why it's not, we don't know how much of it is available as pure hydrogen. A lot of times it's bound up with other things because it's very reactive. And when you burn it, you release water, right? You're oxidizing it with oxygen, you release water. So no CO2 when you burn hydrogen. Lots of hydrogen on planet Earth. There's lots of hydrogen in the universe. It's what powers fusion and our stars and our sun. On Earth, the vast majority of it is bound up in other compounds, hydrocarbons and water, things like that. You often hear about colors of hydrogen, and we'll talk about the colors of hydrogen. I just want to remind you that hydrogen is a colorless gas, no matter where you make it from. And so when you hear about green, blue, gray, pink hydrogen, it's not the color of the hydrogen. It is a way to signify how we made that hydrogen. I don't know who started the color scheme, but it comes up a lot. So we'll talk about the different colors of hydrogen. Today, we make it from fossil fuels, primarily natural gas, also from coal. We make it from other fossil fuels, taking it from those different hydrocarbons. So that's we're getting into our gray hydrogen. That's what we do today. Lots of potential use for our clean energy supply. So like green hydrogen, lots of potential markets, which we're going to talk about today. Right now, it's really used as rocket fuel in an industry. Those are the primary things. I'm putting in ammonia and fertilizer production in that industry bucket. Those are the main places that we use hydrogen today, but there's lots of ideas on markets we could use it for. And one of the things I just want to keep you guys to keep in mind, we've talked about efficiency, we've talked about systems. There's energy losses every time you change energy forms. And so with hydrogen, we want to be thinking about where does it add the most value. And so I'll show you some examples of using different energy sources for different services, and just thinking about how many conversions you have can really impact how much energy service you're getting out of the energy you put in. So I just put some examples here, if we're thinking about using hydrogen for driving a car, for example, or for producing electricity. There's a lot of conversions going from your renewable energy to hydrogen back to electricity, if that's what you're using it for, versus using that electricity directly or even using it in batteries is more efficient systems. So we do have to be thinking about what are the most efficient places for us to use hydrogen as our energy carrier. Okay, so hydrogen, our simple molecule. You guys remember this from chemistry days, right? Our periodic table, hydrogen's way up there at the top. So first element, odorless, colorless, non-toxic gas, highly combustible because it oxidizes really easily. So I mentioned it's abundant. It's what we're using for fusion, mostly in water and organic compounds. When we burn it carbon-free, flame, if it's pure hydrogen, is invisible. So when I worked at Dow Chemical, I worked in a chlorine production facility. The way you make chlorine is by electrocuting salt water. You're using electrolyzers, but we were trying to make chlorine, not hydrogen, but same idea, using electrolyzers. But we had hydrogen as a byproduct because when you're electrocuting salt water, you're separating sodium and chloride, get your chlorine. You're also separating some of the water molecules. You're getting oxygen and hydrogen out of your water molecules. One of the things we had was a hydrogen facility which compressed the hydrogen, and we just put it into the natural gas line. Went to our natural gas combined cycle power plant on site. We just put it into the natural gas and it was burned in the natural gas power plant. But we did have to worry about leaks and flames. And sometimes you could hear the flame, but you couldn't see it if it was coming out of a leak. And so you had to be very careful in terms of just safety around the hydrogen compression system. Okay, and then thinking about hydrogen as a fuel and its density is, from a mass standpoint, is a very energy dense fuel. From a volume standpoint, it's much worse than a lot of our other options. And so when we're thinking about carrying our hydrogen around, moving it around, we do have to think about getting that volume down to make it easier to transport the hydrogen. So you guys have seen this before. This is just that map of energy resources to energy services that we want, right? Hydrogen can fit in either of these buckets, that carrier bucket or the storage bucket. And so we'll talk about that as a market. I put this little question mark over here as an energy resource. Why might I keep mentioning that as like, it's an energy carrier, but could it be an energy resource? Why am I keep putting that as a question mark? What do you guys think? Geologic hydrogen, like we find it just like in the ground, right? Then you can start thinking of that geologic hydrogen anyway as an energy resource. We don't have to do anything to get it. We have it, but it's a big question mark, and we'll talk about geologic hydrogen and what's happening. So just finally in contextualizing hydrogen to drive home this idea that it's a very dense on the mass side. So that's your x-axis, but very, very, on the x-axis, but the y-axis, the volume. Volume is very low in terms of hydrogen compared to some of our other fuels. So that's a challenge hydrogen faces. Okay, so let's talk about our hydrogen colors and how we generate hydrogen. So thinking about hydrogen, like I said, the colors are really just signifying where we get it, and in some sense of the carbon intensity of the way that we're producing that hydrogen. And so some of our more carbon intense ones that produce CO2 are over here on the left. Gray is the main way that we're making hydrogen. It's that methane reforming. There's other ways to make it from methane. Turquoise, brown is making it from coal. So there are carbon intensive ones. And then we have other options for the potential for little or no CO2. Blue gets mentioned a lot. That's making our hydrogen with that methane, but we're capturing the CO2. And so Len talked some about that. Green is making it through electrolysis from renewable energy. And then you can see some of these other categories. They talk about just making it from grid electricity, which might be less carbon and might get greener over time, would be yellow. Pink, making it from nuclear. You can make it directly from some of the steam and stuff from nuclear. And then, of course, underground deposits. I just today learned there's a new category, which we'll look at. There's an orange hydrogen that's also a different way of making hydrogen from underground. So there's new rainbow colors of hydrogen coming. Okay, so I mentioned hydrogen. This is looking globally. It's really produced from fossil fuels. It's natural gas and coal. We are seeing demand for hydrogen go up. Not going to go a lot into the technology on how it's produced. This is showing steam methane reforming, sometimes called SMR or SR for steam reforming. You're basically heating up the methane in the presence of steam and water. and driving off the hydrogen and releasing CO2 from this process. Again, primary way we're making it, if we did this with carbon capture and storage, it would go from being gray to blue. We also can make hydrogen with our electrolyzers. You saw a video, hopefully, about how this process works. You can think about it as it's kind of like the backward of a fuel cell, which is making electricity from hydrogen. Now you're creating hydrogen with electrolyzer. These are the process that I ran at Dow. If you're using pure water, you're getting hydrogen and oxygen off of this. At an industrial scale, then you're really just trying to make sure you keep that hydrogen and oxygen separated. Otherwise, you get them back together and that causes explosions or fires. But this can be done with any sort of form of electricity. So if it's renewables, it's green. If it's just grid electricity, we're making yellow hydrogen. And electrolyzers, there's been a lot of growth in demand for electrolyzers, and that's an indication that there's a lot of interest in making hydrogen more from electricity. And so this is just giving you a sense of where that growth is taking place in the world. China has really grown a lot and come on stage for building more and more electrolyzers and making hydrogen from electricity rather than directly from our fossil fuels. But you can see there's growth in Europe and the United States as well. And a growing number of announced low-emission hydrogen projects. So there's definitely this sense that the market is going to start demanding low-emission hydrogen for different markets. And so we're seeing some growth happening there. The cost for producing hydrogen from these different methods, this is just from one study that looked at the differences. And you can see how it's not cost competitive at this point in terms of doing electrolysis with nuclear, with wind, with other renewables yet in terms of hydrogen. So you do have this kind of premium that you're paying for that green hydrogen, and so we have to have markets that want to pay that premium for the decarbonization aspect of the hydrogen. All right, so that's a lot about producing hydrogen. I want to mention geologic hydrogen as well. I love this little chart. This is from a study that was published in Science and also referenced at the USGS. There's a lot of interest, question, exploration happening right now in geologic hydrogen. I would say it hasn't been mapped out. We don't know how much or how little is there yet. And I think we're learning all the time more about it. We haven't really looked for geologic hydrogen in the past. So this is really a new space. And so what this chart is showing is different ways where the hydrogen is maybe made underground. So you can read more about these in the notes in the slide if you guys really want to dig into geologic hydrogen, but there's different ways it could be made underground. I think this number 2 is probably the most likely for most of the geologic hydrogen, but there's other ways. There's ways that it can be lost, and then there's ways to extract it. And so that's where some of the gold or orange, depending on how you extract it. And can you use iron-rich minerals and actually make hydrogen underground and then extract it that way? A lot, like I said, of interest. This is not done commercially anywhere yet. There are some pre-commercial scale, there's one, at least that I know of, pre-commercial scale project that is looking at geologic hydrogen. And one thing I just learned today is that now people think maybe fairy circles are related to geologic hydrogen. And in this case, they're talking about these spaces where it's a big circle of ground that is it's pretty much in a circle that is a different topography than around it, and it tends to be these very like circles. Anyway, you can read more about it. They think that this may be related to geologic hydrogen. Not enough necessarily to capture it, but a space that shows that maybe geologic hydrogen exists, and we'll be able to find more. So if we had geologic hydrogen, at least I guess in my mind, that would make it an energy resource rather than just a carrier, because we wouldn't have to create it. If we're using the geology to create it, we're making it from iron-rich minerals, we're still creating it. It's an energy carrier. Okay. And then transportation of hydrogen. Hydrogen, again, volume is low. You want to compress it, maybe, get it into a lower volume before you're moving it. Pipeline is probably the most cost-effective way to move hydrogen around if we can build out hydrogen pipelines. But you can't just use the existing natural gas pipelines to move pure hydrogen. I mentioned that at Dow, we put it in to the natural gas pipe system just like on site, but at pretty low concentrations in terms of natural gas. California allows hydrogen to be added to the natural gas pipeline system up to about 5%. You do have to worry about embrittlement of the steel and the welds for that natural gas system from hydrogen. It's highly reactive. It's really small. It can leak out really easily. So those pipeline systems aren't made to carry pure hydrogen, but mixing in with natural gas, using it a little bit, is being done some. Let's talk about the next part. So where do we use hydrogen, and where is it going to go in the future? We mentioned already the places it's primarily used right now is oil refining. You guys already learned about oil refining and how we use hydrogen to upgrade fuels. We use it in our desulfurization processes, things like that. And we use it for our ammonia production. That's really producing our fertilizers. And we'll talk a little bit, maybe ammonia can also be another way as an energy carrier for things like transportation. Right now, it's really a fertilizer thing. And we're doing the same thing in the US. So that was global picture. US, very much an industry for refining, and ammonia, very, very small amount is going to other applications, including like transportation applications. Demand for hydrogen is growing. So this is a chart that's showing it for those main categories, the refining and ammonia, but also other things like methanol production and direct reduced iron steel production. There is growth in hydrogen being used in the steel production. So we are seeing growing demand right now. But the good question is, and I think we all kind of have that question, is where is it going to go in the future? And so there is investment growing. So this is just showing energy and industry investments by technology. And you can see hydrogen at the little blue square at the bottom. So we are seeing growth and investment in hydrogen as interest in hydrogen has really come on stage, and we're seeing it in the VC spaces as well. Where are we going to use it? I mentioned there's lots of different potential markets for hydrogen. So there's heating applications where it can directly replace natural gas because it can be a high heat service. In a lot of ways, burning hydrogen as a high heat service is easier than using electricity for a high heat service. So that there's a lot of potential there. For low heat services, electrification, heat pumps are probably going to be a more efficient option. We already talked about some of the steel and heat and chemical applications in industry. Transportation, we kind of mentioned it's really in the long haul or aviation that I think hydrogen has more potential, but there's a lot of question on can we do hydrogen in those applications versus other types of liquid fuels, for example. And then one I think that's really interesting is more of a longer-term energy storage application. Can we store hydrogen underground or in other places in salt domes, things like that? It's more of a longer-term energy storage, while our batteries are more of a 4 to 8 hour storage option. I think that's something else that people are looking at. So lots of potential roles. Not a lot of this is happening yet. And I want to get back to the efficiency. And so this is just an example for a low temperature heat application. Just thinking about how much energy you're actually getting out in terms of the energy carrier you're using. If you're starting with wind power and you're using an electric heat pump versus a hydrogen boiler. Again, that comes back to how many conversions are you doing to get that service. So this is where, like we talked about carbon capture, hydrogen I think is going to have certain applications where it is a better use of that that energy carrier, and other places where electricity is really going to make a lot more sense, just using electricity directly rather than green hydrogen. And so this is just one example of that, a low temperature application. Mentioned seasonal storage as something that people are thinking about. So our batteries are more minute, hour, day. Can hydrogen bring summer sunshine into the winter as part of our electricity grid? That is something that is being definitely thought about and looked at. How do we really store the hydrogen? One of the places it's thought about is storing it underground in our salt domes. I laugh a little bit because we stored all sorts of chemicals and stuff in salt domes. There's a lot of them in the Gulf Coast and the chemical industry. I laugh a little bit, I think, because I hear a lot about, well, we can just store that in salt domes, and we can store that in salt domes, and we can store our oil reserves in salt domes. We have to prioritize and figure out which things are going to make sense and be cost effective. And they are not an unlimited storage option, but there are applications where we could think about storing it underground. And then the cost estimates for different types of energy storage options, I think this is still pretty early data because we're not doing it a lot for hydrogen yet. But you can imagine that, our salt caverns come in at a pretty low cost. Storing it as liquefied hydrogen, compressed hydrogen, there's kind of different cost estimates depending on how we're storing it. And then, of course, the scale is going to be different depending on how we're storing it in terms of hydrogen. Mentioned hydrogen for transportation. This is just one thinking of where hydrogen would fall. Maybe it's in this middle range, and we would still be using some sort of liquid fuel for the really long haul. I think this is an open question, but it is something that we're still trying to figure out. How do we decarbonize the middle to long range transportation in the most cost-effective way? We have hydrogen in different areas of transportation. We even have hydrogen in things like fork trucks, so we can do it. We have it in short aviation. And then, just to do our efficiency of, using renewable power for green hydrogen to power our hydrogen fuel cell vehicle versus our electric vehicle. As we've talked about again, using that electricity more directly through batteries is going to be a more efficient option for the applications where this is going to make sense, which is really why personal vehicles, our electric vehicles, are really winning out at this point. Talked about hydrogen for steel production. This is growing. There are already options and buyers for green steel or decarbonized steel. It's really going to take that market taking off to really drive it. I'm not going to talk through how it's done, but hydrogen is an option for decarbonizing the steel production in several different ways. And there's different ideas on how that's going to happen. Okay, so when you think about this variety of markets that hydrogen can have an application in, the cost point for that hydrogen can be very different depending on the market. And so this is just one study showing a kind of the willingness to pay for different markets. And you can kind of see why hydrogen would maybe target some of these other higher cost markets first as hydrogen is built out and available. Policy, as we talk about, plays a role. And so the U.S. administration has a goal of reducing the costs of hydrogen. This is the $1 per 1 kilogram of hydrogen in a decade goal. There's a lot of tax incentives in the Inflation Reduction Act. And there's investment in hydrogen hubs going on around the country. And this is just some of the more details of that. If you read the news at all about hydrogen, though, there's a lot of question that's coming out right now. Is the promise of green hydrogen going to play out? There's definitely some challenges they're seeing with hydrogen hubs and production hubs and things like that. So I think there's a lot of question about where hydrogen is going to go. I have a few more slides. It's really just about where it's going and the investments that are going on in the hydrogen space. And the level of readiness for a lot of these things. So I would say, just to leave you with that, is hydrogen has a lot of potential as this energy carrier. I think we're kind of seeing where it's going to fit in the different markets and how policy is going to help bring down costs of production for the decarbonized versions of hydrogen. All right, thank you guys all for your attention.